Hello everyone, welcome back to my channel Geomatics Engineering, and today is the lecture 2 of our PG Diploma in Geoinformatics course. So today's topic is going to be multidisciplinary nature of geoinformatics. So you don't get confused that from where I'm choosing these topics. I already covered about the syllabus that I'm going to cover in a different video, and here in this slide I have also pasted the screenshot of the syllabus that what I'm covering. So I've already covered the introduction to geoinformatics part, and in today's lecture the block 1 unit 2 multidisciplinary nature of geoinformatics is going to be covered. So what will be the learning outcomes from this lecture? So we will discuss the evolution of geoinformatics as a discipline and also elaborate the multidisciplinary nature of geoinformatics. So as we all know that geoinformatics is an emerging discipline in all the sectors, like it is used for decision making and planning purpose, and this geoinformatics discipline is also acknowledged by the scientific community as a distinct discipline. It is also supported by essential elements like in textbook, academic programs, conferences, journals and academic societies. Geoinformatics has also acceptance from academia and industry as a legitimate discipline. So geoinformatics discipline has got approval from different sectors, different societies, different communities to be a different discipline, because as it is an emerging and used in so many sectors, from planning to transportation, telecom, disaster management, natural resources, and so many things have used the application of geoinformatics. First we will talk about the evolution of GIS. So in evolution of GIS, what was the early history of GIS? So in the early 1960s, there was a development in computers and spatial concepts in geography. From there, the GIS has started to be emerged. So after that, so many academic communities laid the groundwork for GIS, like National Center for Geographic Information and Analysis formalized research covering spatial analysis and visualization. And after that, when the first GIS came, so Roger Tomlinson developed the first computerized GIS in 1963. For Canada's natural resource inventory. So Roger Tomlinson is father of GIS, as he first developed the computerized GIS in 1963 and also conceptualized the use of computers to process large amount of data for national land use management. And he also coined the term GIS. And after that, in the evolution part, the Harvard laboratory also contributed in this. So Howard Fisher created the SciMap software program in 1964, establishing the Harvard Laboratory for Computer Graphics in 1965. So that Harvard Laboratory became a research center for spatial analysis and visualization that contributes a huge part in GIS development. So early GIS concepts and applications were pioneered at that laboratory, Harvard Laboratory, in different fields. Here you can see the picture of Roger Tomlinson. He is father of GIS, and Howard Fisher, who created the SciMap software in Harvard Laboratory that is used for various applications in geoinformatics, and it contributed also a huge part in the evolution of GIS. After that, Esri was born. In 1969, Jake Dangermond and his wife Laura founded Esri. As we all know about Esri, we uses the softwares from Esri like ArcGIS Desktop, Pro, ArcGIS Online for different GIS applications. So Esri was born in 1969, and after that there was an application of computer mapping and spatial analysis to aid land use planners and managers. And also Esri developed innovative GIS mapping and spatial analysis techniques, becoming the industry standard. And in the present time, Esri is also setting the standards for GIS. Then GIS turns from research to business. So Esri improved software tools and expanded into real-time project solutions, gaining recognition in academia. Then Esri developed ArcInfo, the first commercial GIS product, in 1981, marking Esri's transition into a software company. Earlier Esri was developed for the research purpose. Then in 1981, its transition into a software company, and then it launches its first commercial GIS product. So GIS now where it is. So now GIS enables millions to create digital thematic layers to solve real world problems, facilitates data sharing and collaboration, leading to the vision of continuous interoperable GIS database of the world, widely used for creating maps to analyze patterns, trends and relationships. And in the future, GIS is also working on web-based mapping, cloud computing, and integration with real-time information. GIS has become relevant to every human need. On daily basis, GIS applications are used in Swiggy, Ola, Uber for navigation purpose. So it's essential in understanding and addressing challenges such as population growth, biodiversity loss, and climate change. And it also provides solutions using a common mapping platform. So as we are talking about the multidisciplinary nature of geoinformatics, so already we can see that how it is implementing in different sectors and how widely it is used on daily basis. So here is an image of Jake Dangermond and his wife Laura, who developed ESRI in 1969. Now we will talk about the multidisciplinary nature of geoinformatics and applications of geoinformatics. So in our first lecture, we already studied that geoinformatics is an integration of different methodologies. It is a mixture of different domains like computer science, geodesy, geography, cartography, remote sensing, GIS, GPS, digital image processing, AI, and cognitive psychology. So our aim is to understand Earth's features and processes to solve underlying problems. Geoinformatics study area can be Earth's surface features including human settlement, road networks, water bodies, forests, wildlife, and demography, etc. And geoinformatics helps us to understand how these features are connected and is crucial for decision making. So geoinformatics has already contributed in so many publications. Like in the field of computer science, there are 35% of total publications that are related to geoinformatics. In physical geography, there are roughly 22% of total publications that are related to geoinformatics. In geography, that has the largest component with just over 51%. And there are other disciplines that has also published their research in the field of geoinformatics like information science, ecology, engineering, geology, remote sensing. We can see that already there are so many publications in the different disciplines where the geoinformatics applications is used. So here is a graph showing that which discipline contributed how much percentage in GIS discipline. Like in geography, computer science, physical geography, information science, these are having the higher percentage in GIS science. And there are so many disciplines who is having the application of geoinformatics like telecommunication, optics, material science, water resource, public administration, business economics, urban studies, imaging science, photographic technology, public environment, occupational health, operation research management science, educational research, remote sensing, geology, engineering. They all are having the application of geoinformatics in their discipline. So now we will talk about the main applications of geoinformatics. So as geoinformatics has become a major tool for collecting information on various aspects of the earth over the last 4 decades. So with the availability of high spatial resolution satellites, its applications have increased significantly across different sectors like in information technology industry, environmental agency, local and national governments are using these data sets, research and academia, national survey and mapping organization, geoinformatics consulting firms, international organization and United Nations. So how these different sectors are using GIS data sets for their applications. Like environmental management is using the geoinformatics for monitoring natural resources like forest, minerals, waters, conservation efforts or for disaster preparedness and management. Utility companies are using these data sets for route alignment for transmission lines, asset mapping to reduce transmission loss, water distribution planning and leakage detection. City municipal corporations are using these data sets for database management for governance, emergency relief distribution, urban planning and forestry. Crime department is also using geoinformatics for analyzing the crime pattern for policing and mapping crime hotspots. Forest department is also using for forest cover improvement strategies or wildlife habitat preservation. Disaster management is using for flood mapping, identification of vulnerable population, rescue and relief operation. In agriculture field, geoinformatics is contributing for crop yield prediction, pest control, sustainable land management, and business decision making, market analysis and penetration strategies has been analyzed using geoinformatics, launching new businesses to identify that which area will be suitable for opening the new business. There the geoinformatics application is used. Medical geography is also using the application of geoinformatics for disease cluster identification, tracking disease spread including COVID-19 is also used the application of geoinformatics. There is also some emerging technologies in geoinformatics like drones. Drones are used on a large range for disaster relief and surveillance, remote sensing and GIS for structural damage assessment. Satellite imagery is used for oil spill tracking and marine life assessment. Some future potentials in geoinformatics side, unlimited applications across various domains will be there, with the potential to significantly impact decision making and improve outcomes for society. Now we'll see some case studies that are based on real-time application and how geoinformatics help them. Like here is our first case study, avenue tree inventory. So our objective for this case study is to understand and address challenges facing avenue trees in urban areas. So our study area is T Nagar, Chennai. So for data collection purpose, 317 tree studies for vital data including their biological name, physical feature, health status, and human-induced factors such as nailing injuries, digging, debris dumping, and paving. So these data sets had been collected for 317 trees. So on this data sets, what analysis has been done? The correlation of data to identify factors in inducing stress in trees, statistical analysis using chi-square methods to assess significance, significant factors identified like injuries, digging, nailing, and after this analysis, what results we got? That there are majority of trees in that area are Samania saman, followed by Ficus religios, Delonix regia, Peltophorum peregrinium, and miscellaneous species. These are some scientific names of trees that were available majorly in that area. So 76 trees are exhibited stress symptoms that are having injuries like digging identified as significant stress in that area. Some dumping waste and paving around trees are not significant stress factors. So major stress factor after the analysis we got to know is digging. So when these results are integrated with GIS. So when all these results and analysis has been updated in GIS database, when we will update the database in GIS, there we can perform different queries like how many trees put to external human induced disturbances, the number of trees on a particular road, like roads having an insufficient number of trees, etc. So these kind of information we can get when we update these database in GIS. So this updated database would also be useful for source of dissemination of information for the maintenance of avenue trees. Such a database could be extended to other metros and useful data could be shared among various agencies involved in protecting the trees. So here we have seen that how GIS is contributing to understand and address challenges facing avenue trees in urban areas. Now next case study is lake and water body analysis. So objective of this case study is to understand changes in geographical extent of lakes, water bodies in and around Chennai. So what is going to be the data says? So Survey of India maps for original geographical extent of lakes, high resolution satellites image for change detection and mapping, human encroachment. So what are the key findings? So SOI maps reveals the original extent of lakes that were unaffected by human settlement over 30 years ago. So Survey of India map gives us the before image of that lake and water body, and change detection analysis identifies reduction in water body extent due to urban development. And this satellite images, with the help of these satellite images, we will identify that how much area of lake is reduced and how much human settlement encroachment is there. So this information can help to government planners to implement measures against further encroachment and improve catchment storage and drainage system. And also modern tools like GIS and remote sensing can mitigate effect of large scale rainfall and reduced flooding and disruption of normal life. So here we can see that how GIS and remote sensing is useful for change detection analysis, and with the help of results we can implement new strategies and plans to save the water bodies. And next here is our case study 3, that is road accident analysis. So our objective is to understand the factors that are contributing to road accidents and develop an intelligent system for accident analysis. So study area is going to be Anna Nagar traffic range, Chennai. So challenge for this analysis is going to be the tabular maintenance of accident data that hinder trend analysis and obscured hidden factors lack of reference to real world location in accident of data. So what will be the solution for this? To develop a GIS based query tool for accident mapping and analysis, main menu with drop down menu, map tools and navigation tools for analysis, output generation on daily, weekly, monthly and yearly basis, facility to find nearest hospital, trauma care centers. So when we develop a GIS based query tool, so what results we can get from there? So early accident mapping we can do their inventory and monitoring, generation for various accident reports based on roads, time, age, sex, fatality, vehicle involved and hit and run cases. Police can generate outputs based on different time intervals. So what will be benefit from this GIS based query tool? So we can easily identify for accident spots, recognition of accident patterns. We can also detect of traffic rule violators by age and sex. We can identify of rash driving, overspeeding, drunken driving and hit and run cases. We can also find shortest route to hospital. So conclusion is to GIS proves that valuable for incident solution with geographic relevance, aiding in effective accident analysis and prevention measures. So here we can see that how GIS is contributing in road accident analysis. So with the example of these three case studies in different sectors, we can see that the multidisciplinary nature of geoinformatics, at how it is using in different disciplines. So what are the employment prospects in geoinformatics? So first we will talk about the career options in geoinformatics. So from last 3 decades there are different employment opportunities available in geoinformatics. Like Government of India is already using the geoinformatics in different fields for large scale employment opportunities, and private industries is also having jobs for data generation, software product marketing, data analysis and management, software development, training and teaching. So which educational backgrounds professionals can get into geoinformatics? So geoinformatics professionals came from diverse backgrounds like from geography, geology, environmental science, botany, mathematics, physics, chemistry, geology, engineering, agriculture and computer science. So it is diversified in different educational background. So who are the employers for geoinformatics? So government agencies, private sectors companies, NGOs, consulting firms. Majority of private sector employment that are related to data generation, marketing and software development are the employers for geoinformatics. So how much percentage share of post? So government agencies employ majority of geoinformatics professionals, followed by private sector companies and consulting firms. Private sector employment mostly in data generation, marketing and software development. So what will be the career growth in geoinformatics? So opportunities from specialization to senior level position, and there is already a continuous demand for geoinformatics professional due to its widespread application of technology in various sectors. Now there are already a different institutes, colleges are providing the educational programs in geoinformatics. So what type of programs are there? So it is ranging from certificate level to doctoral level. Programs are there for few days to 2 to 3 years, and also it is in regular or distance based learning. Different institutes that offer the geoinformatics course are different IITs, triple ITs and so many universities across India that provide the certificate on diploma level, UG level, postgraduate level, doctorate level. So list of universities that are offering this course. So I already provided a table in next slide which have the list of universities who provides this geoinformatics course, and there are also some institute and organization that are offering this course. So I've also shared a table in upcoming slides for these institutes, a detailed table. Let's see the table. So here is a 58 universities list who are providing the course of geoinformatics. So I will share this lectures PDF in my Telegram channel. So from there you can see this list of universities who is offering the course of geoinformatics, and here is the 16 list of institute and organization who is also offering the course in geoinformatics. So now we have already covered the multidisciplinary nature of geoinformatics, application of geoinformatics. So we will conclude this lecture and summarize that what we have learned. So we see the evolution of GIS. Like GIS had the beginning in 1960s as computers and early spatial concepts, and the GIS enabled the millions to create their own digital thematic layer to help solve real world problems of any kind real-time implementation for many daily challenges faced by humans. And with web-based mapping and cloud computing and integration with real-time information, the Internet of Things GIS has become a platform relevant to every human need. So this 3 points shows the evolution of GIS, like how it was earlier, how it is in present, and how it is going to help in the future. So GIS is already, we know that a mixture of different domains. That's why it is known for its multidisciplinary nature, and many geoinformatics institutes are using this for different applications. Many local and government agencies, private sectors are using the GIS applications as it is widely used in different sectors. So here we complete this lecture. I hope you all understood about the multidisciplinary nature of geoinformatics and how it is used in different disciplines. So if you like this lecture, let me know in the comment section, and thank you for being there with me in this lecture. Thank you very much.